Hello and welcome. As Ara mentioned, you're in Changing Perspectives, a deep dive into the security posture of 600 real-world AWS environments. You can, of course, see the report at the URL there on screen, which we will show you several more times, so no need to screenshot that. I'm Andrew Krug. I lead the security advocacy team at Datadog.
Hi, I'm Christophe Tafani-Dereeper. I work as a cloud security researcher and advocate at Datadog. I'm French, as you can hear, and I'm also working closely with our security research and detection team. So we have a pretty packed agenda today, so we're going to get started right away. First, we're going to give a bit of intro on cloud security. What does it mean and how it's a bit different than securing on-premise environments. Then we're going to dive in on the most common ways that companies tend to get hacked on AWS. And then we're going to map that to the most important controls and mechanisms that we can have to secure cloud environments. So what does it mean to secure the cloud? And before we try to secure something, it's generally nice to try to understand how it works, right? So we're going to have AWS or any cloud provider that has an API. And generally, you have your engineers that are going to spin up resources using the API through Terraform or manually or through the CLI. And this is going to be virtual machines, load balancers, virtual networks, storage, and all that sorts of things. And on the right, we're going to have the end users that are going to consume these services. So these are going to be SaaS customers that are going to consume load balancers, other engineers consuming virtual machines, etc. And these two things, the API and the resources that we spun up, are really what we refer to as the control plane and the data plane. And these are the two things that we are going to want to secure. Typically, if we have a control plane that is secure, but we are spinning up virtual machines exposed to the internet with SSH, with a weak password, we're going to have a very bad time. Opposed to that, if we are spinning up very secure virtual machines, but we have our root credentials available publicly on GitHub, it's not going to work either. So ready to have cloud security, we need to secure both. These are the most popular services on AWS that you might have heard of probably. So EC2 for virtual machines, VPC for networking, S3 for storage, and IAM for identity and access management. And so these are so common that if we want to secure cloud environments, we really need to try and understand how this works and what are the most common vulnerabilities. Otherwise, it's very hard to secure most of environments. So the next question is, how is securing cloud environments different than securing on-premise infrastructure, right? And it boils down to two things, mostly to the fact that the control plane, so the cloud provider's APIs, are exposed to the internet. And if you let that sink in for a moment, it means that when you have an on-premise environment, we're going to have this probably behind a firewall. Maybe you have to connect to a secure Wi-Fi to be able to access your control plane, which might be your Active Directory or your vSphere control center. For the cloud, it's different because the APIs are by design exposed to the internet. And if you have the right set of credentials, you're going to be able to do anything you want. And this is why we hear a lot the fact that identity is the new perimeter, because there is no other perimeter than your credentials that you have, basically.
And this is a phrase that gets thrown around a ton. I bet most of the people here, if you're interested in security, have actually seen this quote in a presentation about cloud computing. I actually don't really think that this concept that identity is a perimeter is anything new, right? Because we've all been dealing with all kinds of different identities, in the entire time that we've been computing. Just the way that we verify that identity has really changed. So if we look at it, originally, even in the data center, in the early days of computing, your identity was that you could walk into the room and you could compute on, of course, it was a very large computer back then, but we have all kinds of things like certificates, network identity, kind of the original identity. My IP address is me, usernames and passwords. And with the advent of cloud control plane, we actually add access key pairs. And the only thing that's really fundamentally different about these key pairs is impact. A lot of these identities that we have kicking around on our laptops, our developer machines, are very highly privileged due to the nature of the work that we have to do as engineers. And that, of course, has a much broader impact in an incident than, say, a browser session or a single machine identity or even a leaked access card to get into a data center. And when we think about building sustainable long-term defenses in the cloud, we take that impact of the single incident and we spread that across 2 dimensions. Security of the cloud, aka the control plane, the services that control the creation and destruction of your resources, and the data plane, the governance, classification, and logging of the things that we hold for our users in our cloud environments. And that of course, is always data. And you may now be asking yourself, what are the primary means of attack in the cloud? Now, I like to say if you have the privilege of being in business long enough as a cloud practitioner, one day you're going to show up to work and be the recipient of one of these types of attacks. Some of these aren't really notably attacks, but they are incidents. Leaked access key pairs through any number of means, phishing, accidental commits, etc. An accidental data exposure via a misconfigured resource like a public S3 bucket, or my new favorite, SNS and SQS topics, or a leaked temporary credential via a server-side request forgery in one of the applications that you run on a system inside the cloud. So let's talk for just a minute about long-lived credentials. Who here is running workloads today in the AWS cloud? All right. If you do, you interact with these things. Access key pairs, probably. This was the original way that we all accessed the AWS cloud, is we would get a login, we'd generate one of these long-lived set of static credentials, and these pesky things have a way into making it into code sometimes, or configuration files, or temporary files that get written out by a test suite, and then they end up on the web. And you can see headline after headline related to these long-lived credentials. They're just everywhere. Unrecycled access key, long-lived access key, accidental commit. In fact, GitGuardian, in their state of secret sprawl, said for every 10,000 commits, they found an average of 84 AWS IAM credentials that were leaked. That's a pretty high percent of the time. The problem with these long-lived credentials is not that they're inherently bad, right? It's that they actually never expire. So unless you know when these things are leaked, somebody can sit on them and dwell for a long, long time. And again, they're frequently leaked a variety of ways. So what can we do about that?
Right, because we know we have a problem, now we want to know how to fix it. So let's start by how not to fix it. The first step is to acknowledge that we have different use cases. First one being authenticating workloads versus authenticating users. And this is very different, right? Because you cannot ask a machine to do multi-factor authentication, for instance. So let's dive into these 2 use cases and see how we can solve them. When we mean authenticating workloads, what we really mean is you have something that runs in AWS, maybe an EC2 instance, an ECS task, a container inside of an EKS cluster, and you want to use the API, right? So you're going to want to write a file to an S3 bucket, to read from a DynamoDB table, something like that. So I use the generic term workload, but this can also be a Lambda function or basically any piece of code that runs inside of AWS. And the way not to do it is to hardcode IAM access keys. And there are a lot of ways that this can go wrong. We can have them in user data in EC2. We can have them in environment variables, in source code, in machine images, in Docker images. So that's what not to do, right? And basically, the best way to do it is to use what we call platform identities. And it's the cloud-native mechanism through which you can give a logical identity to any workload inside of AWS. The name is going to be slightly different depending on what is the service. It's going to be EC2 instance role for EC2, the Lambda function execution role, and all these sorts of things. And so really the way it works, we're going to have a look, is you're going to attach a role to your workload. Then what runs on the workload is going to be able to call the instance metadata service, which runs on a fixed IP, 169.254.169.254, which is local. So only the workload on this machine or in this ECS task, etc., can query it. And it's going to reply with some temporary credentials that are bound to the role. Generally, this is transparent. So if you use the AWS CLI or the AWS SDK, you're not even going to see it, but this is how it works. So let's have a look. If we connect to an EC2 instance that has a role attached, and we run AWS STS getCaller identity. So this is basically the who am I for the cloud. We see that we are authenticated as my role and the role instance name being the instance ID. So how this works under the hood, if we just run the same thing with the debug flag, we see that under the hood, the AWS CLI is just basically calling this instance metadata service to get credentials for this role. So the point is we can also do that manually. If we just do a curl to this URL and the same endpoint, we can get some credentials for this role. Just to give some background on how this works and to try to demystify it. That was for workloads. Now, for humans, again, it's a very different use case. And generally, the biggest recommendation is to not use IAM users for a few reasons. But Andrew is going to go into before I get to exactly go into.
Yeah, so basically, you need to be able to access your AWS accounts in order to do your job, right? And we're not telling you, the most secure way is just not to ever have credentials. The problem is that these long-lived access key pairs, they don't really scale very well. We have kind of an offboarding problem because even if you have a DevOps team, what's the first thing you do? You automate granting access. How many people have an OKR or a goal that's deprovisioning for your DevOps team? Maybe you do. But again, the problem is really that these credentials live forever. And applications often end up authenticated as humans, right? Because I'm sure that we've never been in the case where we had a credential and it already did maybe slightly more than what we wanted. And it takes a long time sometimes to ask for another credential or another role. So I'll just take that key and I'll put it in some code and check the features released. So really the solution here is to use single sign-on. And I definitely don't want to just say, wave a magic wand and deploy single sign-on, everything is going to be solved. But for a long time in the AWS cloud, single sign-on was very, very challenging for developers, right? Because we needed to be able to get those credentials back onto a developer laptop that we could use to write some code, use the command line, etc. Well, a couple years back, AWS came out with AWS SSO, and it really bridged that gap. So if you're not using AWS SSO, or it's been a really long time since you looked at what's available, it's now called Identity Center, and it's a great way that you can hook in your AWS organization with single sign-on. You can map rules to people. The command line experience is actually excellent, and you can chain that to your existing identity provider. So whatever is providing your OpenID Connect flow, your SAML, it's standards compliant, right? And this results in a reality where your devs are only ever using temporary credentials. And that means phishing's out the door, malware's out the door. There's no threat that they're going to leak those access keys. And even if they do, they're only good for 15 minutes at a time. And it's a much, much better experience if you have moved to a multi-account model. How many people in the room are using more than one AWS account? Yeah, the majority of you. So if you are, you know that credential management in a multi-account reality is way easier if you use a single sign-on provider. So you might be asking, what about legacy applications? I'm not going to do the show of hands to see how many people are hybrid, but if you are hybrid, or maybe you run a workload in another cloud, you need a way to get an AWS identity to that other cloud environment, to that hybrid environment. For me, it might even be a Raspberry Pi that runs in my wire closet at home. And that's where this new service IAM Roles Anywhere comes in. You can actually chain the vending of these temporary credentials to something that we're actually pretty darn good at taking care of now, which is certificates. So the back of this can be an HSM, whatever you use for PKI, and then you can take that certificate and you can give it to an AWS API and exchange it for one of these temporary credentials. And then you can access all of these other services in the AWS cloud from your additional cloud provider, from that Raspberry Pi that lives in your wire closet, from your on-prem environment. So enough about that. Without further ado, let's look at the facts from our report, a look into real-world AWS environments. And again, that URL is up on the screen if you want to check out the reports. I love the hero that we have for this with the owl and sort of the AWS river up there on screen. Looks great. This report is our first security report, but if you haven't heard about our other reports, we actually have a number of these research studies that come out each year, like State of Serverless and State of Containers. So you'll probably want to take a look at those as well.
Great, so let's have a look at the first set of findings that is about, you guessed it, IAM users. First thing that we saw is that 40% of IAM users are unused, which means they haven't logged in the last 3 months. And that's both for users that are with an access key or the ones that have console access. And this shows typically that these are users that are not used anymore, which correspond to nobody in the organization, and that still represent a risk because they have active credentials that can be leaked and used by an attacker. So that's also a good point to show that it's very hard to manage IAM users at scale because the deprovisioning is hard. And basically, when we create users, we know we're not going to break anything. When we want to deprovision them, we say, maybe this is going to break this production application, so just in case, I'm not going to do it. Second figure we have is that 40% of organizations do have IAM users that can log into the AWS console without multi-factor authentication. Again, this means that these users can be phished, there could be some password reuse, and this makes the risk pretty high. The last figure we have for IAM users is that 75% of IAM users, so 3 out of 4, have an access key that is older than 3 months. And typically, the best practice guidance and some standards are telling us that when we have access keys that never expire, we should be changing them and rotating them. Otherwise, the risk that they are getting leaked is very high. But the point is that this is very hard to do, and actually no one does it because it's too hard. Which brings us back to the point that we shouldn't be using IAM users at all when possible, which is most of the time. The latest fun fact is that the oldest access key that we found is actually 13 years old. So it's soon going to be old enough to vote. Yeah, so again, this shows that when we have some access keys, we forget about them, they are still a risk, we never rotate them, so we shouldn't be using IAM users at all. So what does this mean? And Andrew is going to tell us what he thinks it means because he has a lot of opinions on the topic.
So this really means that a large portion of IAM credentials are at risk, right? Either because they don't have multi-factor authentication, they're very old, they're mismanaged, and organizations in general just still really aren't mature in the way that they handle these accounts. We're all striving to get better, right? And the good news is that identity is getting a ton of attention, and the tools are better than ever. So I guess the call to action here would be if you haven't looked at things like permissions boundaries, if you haven't looked at things like organizations and SSO in a long time, go reevaluate those things if you're not using them today. But let's change gears a little bit and look at more of the misconfiguration side. We talked about how data might make it out of your environment, right? To people that you didn't intend to have access. Small piece of trivia though, what do you think all of these years have in common? Anybody can just shout it out. These were all years that there was a public S3 bucket that was the result of a data breach. And you can see, without picking on any single incident here, that these are actually very impactful incidents. So it's almost always, when it hits the headlines, there are millions of records, right? And this can be quite expensive for you as a company if you can be proved to be negligent in the handling of your users' data. And there's a whole host of reasons, right, why a well-intentioned user could accidentally create a public S3 bucket. Everything on the spectrum from third-party software has bad defaults to confusing UX inside of the cloud provider's console itself. Your users generally do want to do the right thing. I don't know anybody that wakes up and goes to work in the morning and says, you know what I'm going to do? I'm going to be the root cause of a data breach today. You're just challenged in understanding the impact of your actions, right? And that's the thing that we really need to change here. Is we need to connect understanding the impact with the action inside the cloud provider environment. Even with all the awareness and headlines around why it's problematic to have public S3 data, there's a lot of organizations that still embrace that behavior. Mind you, a lot of these are, again, legitimate use cases because S3 is great for hosting websites. In fact, if you want to move a static website and immediately have 5 nines, it's probably the best place to put your static website. We just need to know how many of these are actually unintentional. So when we put this fact up on screen here that says 36% of organizations have public buckets, that's not necessarily inherently all bad, but what we have to ask ourselves is what percentage of these are just sitting out there full of data that shouldn't be public?
Great. So if we just pause for a minute and we sum up, so we saw that the first two very common causes for data breaches in the cloud are public S3 buckets, that's not new, and long-lived credentials, very often caused by IAM users. And the first one is about server-side request forgery. That's a mouthful. So I'm going to say SSRF with my bad French accent, but you're going to get it. Okay, so what is server-side request forgery? It's an application-level vulnerability that, again, is not new, but works like that. So you have a web application that sits on some kind of perimeter. Typically, you have an internal network or some kind of boundary. And when this web application takes as an input an URL or a way that is going to fetch something else, so let's say you have a web application that can fetch previews of websites. If you pass it bbc.com, it's going to go to bbc.com, fetch a preview, and show it to you. Now, what happens if you give it the internal URL of a server that you shouldn't be able to access is that basically, as an attacker, you are able to access something you shouldn't be able to. What this means in the context of AWS, if you recall our friend, the instance metadata service, is that if you pass it the URL, the IP of the instance metadata service, you're going to get back some credentials for the role attached to your workload, which is pretty bad, right? If, as an attacker, I can just pass an attack, these 169.254, 169.254, and I get back some AWS credentials, I can just put that inside my console and do anything I want with it. This is pretty bad. So this is actually not new. I wrote about this in 2017. I wasn't even doing security. I found it by accident in a product I was using. And since then, a lot of people have warned about the dangers of that. So, you know, in terms of that you can use it in different input places, like in HTTP headers, in query parameters, in all sorts of crazy things. If you go to HackerOne, you will also find a lot of reports that say this is an issue. We still find bugs where you can exploit this to get some credentials. And this is a good way to pivot from a data plane vulnerability to control plane credentials as well. And very often, these applications are overprivileged, which means you start with an unauthenticated access and you end up as an admin of the AWS account, which is bad, right? So what can we do? We have a problem, we need a solution. AWS did introduce a solution in 2019, which is a version 2 of the service. And they called it the Instance Metadata Service v2. That's a mouthful as well. The way it works, we don't need to go into detail, but basically, before being able to call it, you have to first make a put request to this service. You get a token and then give this token back every time you call it, basically making the service stateful, which means that it's much harder, if not impossible, to exploit with the server-side request forgery. Now, that's good, but what we found is that 93% of EC2 instances don't actually enforce usage of this service, which means that this is a very effective control, but it's not really used. Part of it being because it's not the default when you run an EC2 instance. So one thing that changed very recently, actually I think 2 weeks ago, is that AWS gave you the ability to add a flag on a machine image to say, whenever we run an EC2 instance from this AMI, I want it to be enforced by default. So really that shows also that when we have security mechanisms that are not enabled by default, when we make it hard for people to do the right thing, surprisingly, people don't do the right thing. And that's something that as an industry we are picking up and we need to get better at.
So if you do want the tweetable slide of the day, this is definitely one of the tweetable slides, which is what do we do about all this stuff? And this is kind of the one slide version of this. We have a blog post that actually deep dives in detail on securitylabs.datadoghq.com. So for identity, again, deploy AWS Identity Center. Really lean into single sign-on to eliminate long-lived credentials. Leverage things like advanced IAM permissions to really get to that place of least privilege. You can do it today more easily than ever. And audit access for anomalous behavior, right? Look at things in your logs to know when one of these things gets out the door that somebody's using it in a way that you didn't intend. As far as public data exposure goes, have a data classification system, manual or otherwise. Log your data plane events. One of the worst days I ever have as an incident responder is showing up to somebody's worst day on the job and saying, I actually can't tell you if anyone accessed your data because you don't have the logs. Using multi-account also is a great way to limit the blast radius of a single incident. And for SSRF, as Christophe mentioned, just moving to that new version of the metadata service is really going to eliminate the majority of SSRFs. And of course, if somebody does get an SSRF or a credential and your instance has the least privilege possible, that incident is going to be much more impactful. You can employ detection mechanisms as well to detect SSRFs. Like our ASM product, for example, will detect an SSRF. The biggest piece of advice, though, is actually know when something is misconfigured by leveraging a tool like a posture management product. And this isn't a sales pitch for Datadog CSPM, just saying use ours, use somebody else's, use something open source, but please scan your environment regularly and continuously and follow up on those findings. As far as resources go for the session, full study available here at the link on screen. Datadog Security Labs website, if you didn't catch that URL. Christophe also has another great talk out there called Fantastic AWS Hacks and Where to Find Them, which is a deep dive on a variety of incidents. And assume that someday, again, if you are in business long enough, that you're going to have an AWS security incident, which is where that final resource comes into play. That is a white paper on IR, all the planning you can do to kind of get yourself set up for an incident, how to run an incident, a security incident inside the AWS cloud. And you can, of course, follow us on Twitter for lots of hot takes and updates as we continue the research work that we do together. We're not stopping, right? We're going to continue this series of reports, and I bet you could predict the future, where we might go next, some other things that we might look at in cloud providers that are not AWS. So thank you again for attending our session. I'm Andrew. This is Christophe. We're from the security advocacy team at Datadog. We hope you enjoy the rest of Dash. We'll take some questions as well.
Thank you.
So if you have questions, please stand up and go to either of those mics.
Hello. So I have a question about the identity provider solution. I have a use case where I'm trying to give an external customer write access to S3 so they can upload files to us. We don't necessarily want them in our IDP. What would be a recommendation for that kind of approach?
Do you want to take this one?
I can start and you can complete if you have some more opinions. So that's a great point, and that's the third use case, right? You have a third party that you want to give access to. It's going to depend. So typically, this might be a SaaS application like Datadog that you want to be able to access your account. So there, the best practice is to create an IAM role, to delegate access to a role that this SaaS provider is going to give you, and to use a random external ID in the role trust policy to make sure that there is no confusion on which customer on the SaaS side can access your data.
Yeah. It's not a SaaS. This is
right.
Yeah.
And in the case where it's a third party, generally, if it's a third party that uses AWS, the best practice is to create an IAM role that they can assume from their own AWS account, which means they don't have any long-lived credentials again. And this way, it's pretty easy for them. They can automate it as well. And for you, you can control what the role can do. You can control for how long the credentials are valid. Add some permissions, boundaries, and things like that.
Yeah, I've got that one, but I don't have the case where they don't have an AWS account. And I still need them to get me the data because it's in their SharePoint or whatever, and they're trying to copy it out. And I'm giving them access to an S3 bucket to put it in. And the only way I've come up with that is to create an IAM user that's locked down to only be able to write to that S3 bucket. Is there a better solution?
Cross-account is definitely the recommended best practice. So if that was me and I was in that same position, I would be encouraging that third party to go out and get their own AWS account. So then you're kind of like shifting that responsibility of managing those credentials, however they do, onto them. And all you're responsible for is delegating access and auditing it, right? You can do a ton of stuff in the S3 bucket policy and the cross-account role to further restrict things like IP address that they're coming from, AWS regions that they can access, and just really whittle that down to the bare minimum. So that'd be the guidance.
Thank you very much.
Sorry. I want to ask about the metadata service, the new one. At what level or what layer is that enabled at? Like, is that something that can you do it on an existing AMI or an existing instance if it's not already there, or do you have to kind of recycle all of your AMIs or make new instances?
So you shouldn't have to repack any of your images or rebuild your AMIs. It's actually a setting that's part of the configuration at launch, and it's editable after the instance is launched. So it's just a change in what services are available on the localhost binding.
Okay. So even on a running instance, it can be turned on.
It might. I'm not sure if it requires a reboot or not. I can't remember.
It does.
It requires a reboot. Okay.
I didn't know if that's something that they recently updated, because I know until very recently you couldn't change the instance profile without a reboot, but then they did change that behavior. But yeah, if all it requires is a reboot, it's pretty minimal.
Okay. And one thing that's also useful, so in the blog post that we had before, that's linked there, we link to a tool that is not from Datadog, but that helps you find which instances are using the old version of the instance metadata service and how you can migrate to the V2. With some examples.
Thank you.
Along the same lines, because this is a fun topic, not again a sales pitch for CSPM per se, but saw that pop up for a bunch of stuff in our account recently, and it's been kind of pissing me off because that's on managed EKS nodes, right? And so I'm curious if in some of the policy changes that can be affected, if that covers those sort of secondary or tertiary sorts of resources that get spun up by other managed services that we would use within AWS, or if we have to go through and explicitly add more automation to pass back over them, or periodically audit and update all that as they run.
I can answer about the specific one, and you can take more generally. So for EKS in particular, I did spend a lot of time trying to fix it as well. So the best way is to basically manage your own node groups, where you have to provide your own launch configuration. And in that launch configuration, you can say, I want to enforce the instance metadata service v2. As far as I know, you have no way when you spin up an EKS cluster with an AWS managed node group to say, go ahead and enforce it.
Okay, thank you.
And I would say as well, keep in mind that the actual EKS team at AWS maintains an open source set of GitHub issues. So if you really think that it's cool that that's the default, I'm sure that somebody's already opened the issue, go thumbs up it.
Yeah.
Because that's the way that stuff bubbles to the top of the stack, right? But I think that we're at this kind of tipping point now where it's very much starting to become the default for both managed services and customer environments.
And just to add something for EKS specifically, one of the issues for EKS in particular is that by default, from a container, you can access the instance metadata service of the instance, which means that by default, if you compromise the container, you can get the credentials by design of the whole instance, which is bad. So the recommendation for that is to enable IAM roles for EKS services, which means that you can give a logical identity to each pod. And on top of that, you have to block the instance metadata service. You can do that with an IP table thing, or with a network policy if you have a network provider that supports that.
Hi, thank you so much for the info. I had a question about identity user management for RDS. We recently made a switch to SSO, which doesn't support IAM authentication for RDS. And we're trying to figure out a best strategy, either creating actual users in the database or creating separate IAM users just to access the database. But that's become a problem that we're not sure the best approach.
Yeah, my answer here would be almost different for every use case, depending on the data that you're storing in the database, right? Because at the end of the day, all that RDS is spending the database engine on top of AWS as a managed service. So it's going to be totally dependent on platform, right? What the right thing is to do there. The most important part is that you just eliminate as many of those static credentials as possible. And RDS is almost kind of out of scope, but there's some very cool access proxy solutions and things that you can use as kind of like a middleman in there. I can't recommend any specific ones, but there's a lot of them out there.
And one thing that I've seen people done, if I'm not mistaken, is to start from SSO, which you cannot map to RDS IAM, and then to go and assume a role that can access the RDS instances.
Okay.
But I think your specific question is actually about data access, right?
No, it's about the database, accessing the database.
For management events, like control plane, like snapshots, backup.
No, like let's say we want to give our engineers logins to the database for like read only or something that maybe they need to write. You know, it's like one approach could be just to create MySQL users, or you could create IAM accounts, IAM users, and then use that to authenticate RDS.
Yeah.
But like, yeah, we need to give developers access to the database. We're trying to figure out the easiest way to manage it without having to recreate all of our user accounts.
Yeah, so again, when you have the solution where you have an SSO role that can assume another role that you map in ARDS, that's good because you can easily automate it in AWS Vault.
Mm-hmm.
And so in one command, the developers can get a profile that they can use. It's pretty seamless.
So roles can log into RDS?
As far as I know, yes.
Okay.
I think it's provider dependent sometimes, but I could be wrong. This is not an area I deep dive in super often.
All right. Well, thank you.
Sounds like it'd be a great blog.
Yeah. Appreciate it. Thank you.
Thanks for the question. I think we probably have time for one more question. If anybody else has one more.
Or one comment.
One comment, even.
Thank you.
So Datadog provides SSO authentication, but when I try to log in with my account, I don't receive any emails for authentication. Does it mean like that central integration with Datadog is not configured for our company identity provider? What do you think? Right now, we're just using username and password that's not really secure. So
was your question? Correct me if I'm wrong.
For Datadog, there would login to kind of ideally, I would use the SSO provided by my company. So identity providers for my company, but it seems like it's not integrated.
So Datadog does support standards compliant single sign-on role mapping. If you are, did you say you're using that or not?
I'm trying to use it, but like Datadog says, like wait for your email and you will get like your link to single sign-on, but it never comes. So I suppose that on the like company level integration with Datadog, there is no the SSO is not really integrated here. So.
It sounds like a great question for support. I can tell you, I personally actually configure single sign-on with my personal Datadog account against G Suite, and it works 100% of the time. So definitely, I would follow up with support to see if they can help you figure out how to get that link, why it's maybe not coming into your mail system.
Sounds good. Thanks.
And again, thank you for being here. Check out the report, and if you have any questions, feel free to follow up with either of us.